I don't forget. But yes, so it's my pleasure to welcome Carsten Sørensen, who is a reader in digital innovation at LSE. And he has researched, for example, digital enterprise through mobile technology and innovation dynamics of mobile infrastructures and platforms. Amongst many other things, is also academic consultant and executive education with a broad range of organizations. And over to you, Carsten.
Thank you very much. It's a pleasure to present here. One of the things I did many years ago was to be principal investigator in LSE's projects with something called the Mobile Virtual Center of Excellence, which is where I met Sri. And we had a great time working in one or two projects with this outfit from 2008 to 2012, which, of course, next year is a whole decade ago. So time flies, make the best of it. I'm just going to share my screen here. So give me just 1 second. So I will post a link to the slides in the comments after I'm done. So for those of you who might want them, you feel free to take a copy. I'm also very happy to connect on LinkedIn, also on WeChat, but I only start WeChat whenever I'm in China. So I'm going to talk about the age of value-sensitive digital infrastructures. And the first thing I want to say, really to frame this, sort of knowing who you may be, although I don't know you in detail, but I never wanted to be an HCI expert in video conferencing until the COVID started, and it turned out I had to have this cockpit at home with all sorts of equipment. And I would say in the same way, most of you would probably think that your research and activities have very little to do with, for example, blockchain or any other distributed ledger. But I would sort of argue, or we can have a discussion on that, but I would argue that maybe it will become important even in your research at some point. And that's really the essence of this talk. So I'm sorry the talk might be a little bit fast at times, but the slides are there for more detail. And I want to make sure we have a little bit of time at the end to discuss. And if you have any clarification questions, please do interrupt. So why is infrastructure important? Well, it's an interesting question. My Siri watch just said, and it is indeed an interesting question. And we can see here on the left side what happened in Sweden the day they changed from driving in the left side to driving in the right side. And it was utter chaos. And of course, the internet is interesting in the sense you can drive in pretty much any side you want, as long as you follow some basic rules we're going to talk about later. But what we've done on the internet is we have built now a set of institutions, commercial companies that act as institutions in the physical world. And the way we understand those as traditional infrastructures is that they enable various kind of things. They don't necessarily do a lot on their own, but they enable a lot of other activities. They are shared, the infrastructure is shared, that consists of standardized interfaces between the elements, and there's a degree of openness. That means that you can have unlimited number of entities that are stuck together. And this creates a really interesting phenomena that allows things to grow on top of the infrastructure, so the open internet. I've listed here 3 books I really like that relate specifically to infrastructure. One is Tom Standage's book about the Victorian internet that argues that if Queen Victoria was alive now, she would not be impressed with the internet. She had one of those. She would be impressed with international airlines, the airplanes sending us from country to country. The telegraph system was in effect an internet system, and it's really interesting to read Tom's exposure of all the aspects we think are unique to the internet that actually were already there very early on in the Victorian age. Joan Yates' book about how we learned how to manage large distributed companies through technology is a fantastic book, as is Bowker and Starr's book on global classification schemes and standard infrastructures that support interaction remotely without needing to coordinate. So the highlight of the story is really just to say that the World Wide Web is sort of undergoing some eras of change, where the first one was really just the establishment of the ability to post web pages. The second era, from around sort of just before the dot-com boom and bust in 2000, was really about using the open internet as a way of interacting with each other through various kinds of services, through all of these middleware layers and the digital platforms. And the resulting global digital platforms have now given rise to what we call Web 3.0, where the idea is that you do not only send data on the internet, but you also have a way of keeping track of things that are important and have value. So what I'm really going to say today in this talk is we have an understanding of what an open internet and an infrastructure is that is based on Web 1 and Web 2. But what is happening is very rapidly we are building a new web, a Web 3. And that is extremely important to understand that, because it has some properties that are important for everything we do. And it is far beyond just Bitcoin. But before that, I'm just going to very briefly give my take on the story of what is different between digital technologies and other kinds of innovation. And so here I've taken the example of music. There's some music recorded somewhere on some medium on the left side. So the abstract notion of a piece of music, some sound waves. And in an analog world, what's characteristic is that there's a tight coupling between how this music is stored, how it's processed, and how it's distributed. So you have what is called an industry vertical, where you have companies that sort of are aligned as a stack of plates in your cupboard in the kitchen, that each level of a given stack, people stay there and they basically have to compete with only people at the same level as them. So Technics that makes turntables, well, they only have to compete with people who make turntables as well. And of course, what happens once you digitize music, then you loosen those couplings. So this is what happened when MP3 and fast internet and more storage meant that suddenly you could store it on anything that could store 0 and 1s. You could process it on anything that had a CPU and a bit of memory, and you could distribute it on the open internet, here, the blue IP box, which is the internet protocol. And of course, because the music industry already had digitized all music on CDs, it was ready to be ripped, mixed, and burnt. This caused massive fragmentation, and people took the music themselves instead of paying for it in peer-to-peer networks. And then Steve Jobs from Apple and others made deals with the music industry that basically re-established this kind of vertical arrangement, where Apple now was in charge, and later Google and Amazon and others were the ones in control of this vertical arrangement. But the point is here, this was all based on the simple assumption that people want to buy music to download and own. They want to own the bits. It turned out we don't want to own any bits. It turned out we are quite happy streaming on Spotify, Apple Music, YouTube Music, or whatever. And so the point is there, we saw a very quick change in how the internet infrastructure allowed radical change in how money was made, how people work, how consumption is happening. And I just have a very brief other example here, which is London black cabs that we spent a lot of time studying many years ago, that really the job of being a cabbie in London is almost as old as being a university worker. And that Uber managed to completely disrupt that in exactly the same way as Apple managed to disrupt the distribution of digital music. And this is happening because digital technologies is different from other technologies. That is the essence of it. And one of the key differences is really to have to look at the infrastructure, the underlying mechanisms that allow all of this to happen. And the ones we have mostly, the open internet is what I would call value agnostic infrastructures. The infrastructure itself doesn't care what the bits are about that are transported on them. So here on the left side, I have this example from Steve Jobs when he was younger. He made this blue box with Steve Wozniak before Apple, where they found sort of a slight error in the operating system of AT&T's phone systems, namely that the operating system commands, they were at the same frequency level as the human voice. So they built this blue box that allow you to basically subvert billions of dollars of infrastructure, and you could just get free phone calls around the world. They called the Pope, and they woke up the Pope, but they freaked out before the Pope got to the phone. They pretended to be Henry Kissinger, who was the foreign secretary then. But the point is that the open infrastructures we have there, sort of layers upon layers upon layers of networks that have collected themselves to become the network of networks that we call the open internet. And really the way to look at it is, and this hourglass figure on the right, and there's some engineering research have promoted this view, but in particular, this is from a guy called Jonathan Citrain. So he wrote a book in 2008 called The Future of the Internet and How to Stop It, which was all about how the internet was so open-ended that you could make all sorts of bad things come out of it. So he explains the internet, open internet, as any service on any underlying infrastructure. The only rule is you need to follow the rules of the IP protocol at the center. And if you look at mobile networks, for example, they have developed to become more and more IP-centric. That it's really 5G networks allow high flexibility because it's based on this open package architecture. So the point is here that the open internet is value agnostic because it doesn't care what the value is about. It doesn't care whether it's just free information or it's something that should be paid for. And that has some consequences we're going to look at in a second. But of course, the problem is here, you can change the open internet as much as you want, as long as you don't want to change that little blue box in the middle. And here we have Vint Cerf, who was together with Bob Kahn, were the two guys who invented the internet. And people have put him on this poster in Amsterdam, I think, some years ago, to tell all webmasters to upgrade to IP version 6 compatible servers. And there's also a picture of me where I had my rock and roll moment meeting Vint Cerf at a Google event outside Paris, and I had dinner with him and his wife and had a great time, spending all night talking to him about how he invented the internet. So that's why I look like such a happy camper. The point of this is, as we've described, David Tilson, Kalle Lytinen, and myself in a paper from 2010. So when we have these digital infrastructures, as opposed to the road ones or the railway ones or the gas ones, that they are really governed by two paradoxes. So there's the paradox of change and the paradox of control. So the paradox of change basically says that the open internet has continually changed while it has remained stable. So the blue box has been relatively stable, but everything around it has undergone significant change. If it hadn't, we wouldn't be using the internet. It would only be people in white lab coats on science labs that might use the internet for some scientific collaboration. So maybe us here would use it, but my dad would definitely not have been using the internet, and my daughter certainly not. And so the point is here, the success of the internet is this dynamic change to match the demand. At the same time, the control is both centralized and distributed at the same time. So it is highly centralized when it really gets to the basic elements, but it is highly distributed, controlled in a highly distributed manner that allows anybody to do new things. So, of course, one of the things people can do with the open internet, they can build blockchain infrastructures on top of it. And so the next slide I'm going to skip. It's just for those who are particularly interested. But there's a lot of different, well, we can return to it if you have questions, but there's sort of a more complex explanation on why this paradox is so. And the essence of it really is the digital material it's built off allow this flexibility of sticking things together in a different manner. Now, the point is here, because the underlying open internet is value agnostic, when we want to exchange things that have value to us, then we need to do something else. in order to capture value, we need to invent something to capture value. And we found a particular way of doing that, which is called the digital platform, that I've spent ever since I was in a project with Sri back in 2008 studying. And this has later become a really popular topic of study, way later than I began. And there's some people here, Annabel Gaver, who's a professor at Surrey University. I think is the leading platform academic in management science. She started with her PhD at MIT in 2001. Well, she wrote the book in 2001, so she did her in the late 90s her PhD on this. And she's co-authored a recent book with Michael Cusumano and David Yoffe on platforms that basically argues that there's sort of two kinds of platforms: those that support transactions, buying stuff on Amazon, and those who support innovation like Amazon Web Services. And then there's a cross section here in this Venn diagram where the app stores, for example, they basically allow both transactions and innovation. So they have a core operating system and APIs and SDKs that allow complements to be made in an uncoordinated or loosely coordinated manner. So there's a lot of discussion on this, which we're not going to go into now. The essence of this is, of course, as the old, I think, Nintendo game meme that says all your data are belong to us, is, of course, the side effect of this arrangement is the assumption they're built on these platforms is that data has no value. Data is just some byproduct of transactions. But as we've seen now with particular Facebook and Google and Microsoft, that all three organizations made a huge amount of money on the data because it fuels advertisement. And so the point is these platforms, they push paid human effort to the edges to either be free, done by customers, or be low paid, done by Uber drivers, and they push the core innovation at the center, but then they get to keep the data. So in this distinction on the left bottom side here, between services as value propositions or value creation, platforms as a way of capturing value, and infrastructures as a way of delivering value, there's very little emphasis on the infrastructure because on the digital economy, we have all paid for our infrastructure. I have paid for my fixed line connection. I paid for my mobile data connection. So Apple and Google doesn't have to pay anybody to deliver this in principle, although it's not quite true. But the point is here that Amazon makes much less money on packaging than on web services because they have to pay a lot of delivery drivers to actually deliver the packages. Whereas the digital packages are delivered on an infrastructure that is collectively paid for. And the problem we have then is how can we get the best out of these digital infrastructure arrangements, for example, in platforms, without having this uncomfortable problem that Shoshana Zuboff raised in her book about surveillance capitalism. That was really the ground for the Netflix documentary, The Social Dilemma. So Shoshana is an old friend of ours here, and I have a signed copy of her book. I met her and talked to her about the book, which has become extremely important in the public debate also of whether Facebook should be regulated. So she basically, in the top right-hand corner here, asked three questions. Who knows, who decides, and who decides who decides, so who governs? And this is the key point, is that the platform economy is not very good at handling this because there is only really one answer to that in most cases. Facebook knows, Facebook decides, and Facebook also regulates, although they have now some ethical committee where Nick Clegg and others sit in. So this gets us to the real meat and potatoes of the talk. And we are roughly halfway, maybe a little less than halfway. So that is value-sensitive infrastructure. So the argument that really the talk is all about is, on the one hand, you have the value-agnostic open internet, that in order to exchange things that have value not only in use, but also in exchange, we need to work out something. And what all we've managed to work out is either some peer-to-peer arrangement between firms or between individuals, or we have these platforms that are in the middle that serves as trustworthy mediators. So when I buy a bicycle from somebody on eBay, if I don't get the bicycle, I will get my money back. And if the person who sells the bicycle doesn't get the money, they don't have to send me the bicycle. So the point is here, what we're thinking about is this explosive need for have something that is not only valuable, but also digital. So far, the open internet only allows us to have digital things if they don't have any value. So what happened with music as it became digitized, every song drove down in value because they could be shared freely or they became part of a subscription. And so musicians have really fared poorly from this development, most musicians. But if you want to have all sorts of digital assets, certificates, digital money, all of these things, we have to solve what's called the double spend problem, which is if I have a £10 note and I give it to you, then I can't claim still to have it. I have given it to you. When we digitize things, we need to make sure we can't double spend. And so for that purpose, you have one thing is called a blockchain that will help with that. And a blockchain is really just a way of having all the data replicated with everyone, so we all know and agree on who has what coin at what point. And you establish that in one of two ways, either, well, in one of many ways, but two main ways. Either you have a proof of work, which is a complex cryptographic puzzle, and whoever that runs a full version of blockchain guesses the solution to this puzzle will get now, it's not 12.5, it's 6.75 Bitcoin, I think. I can't remember whether they've changed or not. I don't have any Bitcoin, so I don't follow this. The other way of doing it is by voting. It's proof of stake, is that you vote according to how many coins you own. So you stake your coins on believing a certain transaction or bundle of transactions were true. And if you're wrong, if you back on something that's a hoax, well, then you potentially lose some of your money because some people will steal money. So this is really, and a blockchain can be that, as first we can see it as, imagine if there was a coin, a £1 coin in all of these, between all of these shopping trolleys. That's really what a blockchain can be seen as a first optimization or first approximation. There are many different kinds of proofing mechanisms, but these two are the two most common ones. It is a very busy slide. I'm not going to go into detail, but this is really just the one slide highlight of what happened with Bitcoin. When did it start, and where is the white paper? Is Nigel Farage really Satoshi Nakamoto, who's the eponymous founder who has never been revealed, and all of these things? And the point is there, the middle box is really maybe the most important thing. If you want to think of things that have value like money, well, they can either be there's a unit of account, there's a medium of exchange, it can be a store of value, and it can be a way of handling deferred payments or debt. So the point is here, what's really important in all of this is that when we look at the use case for Bitcoin is really so far mainly as a store of value. It's a way, as a deflationary way of making sure that if you put money in your mattress, it will be at least the same worth, if not more, when you take it out in your old age. If you stitch all your savings in a mattress, it will be worthless, near worthless after a lifetime of work. So this is really the important reason why Bitcoin started. But the technology itself has got so many purposes that it is very dangerous to only look at it as a way of having a new kind of money. But we're going to get back to that in a bit anyway. So the way to understand what is happening in this kind of infrastructure is really to say there are three elements. These are the three necessary and sufficient components for having a blockchain, or generally you could say a value-sensitive infrastructure. You have a coin, you have some notion of a shared, a scarce digital right that you want to be able to exchange with others. And that is closely linked to the network. So you, instead of having a £10 note that can be sent over Visa's network or PayPal or just given in an envelope or handed over by hand, a Bitcoin or a Dogecoin are intrinsically linked to the network. They only exist on the network. Once they leave the network, they are gone. They don't exist there anymore. But most of them will just stay there forever. There's lots of them are lost because we don't know who owns the account, but they all are there. But the most important element is the third one, which most people tend to not think too much about, which is the community. So the key in this kind of infrastructure, it's not just defined abstractly by somebody and then anybody can use it. No, there's key community that makes sure that it starts and that it functions, that it's sustainable. And this is really important. And the reason why they are necessary and sufficient is really shown here. So if you only have a connection between the coin and the community, Well, that's what we call a client-server database. If we only have a connection between the coin and the network, well, you can explain that as a digital platform. That it is just what happens when a platform sits down and say, now I'm a guarantor of interaction between multiple parties who want to exchange things over the platform. And if you only have the community and the network, but without any coin, that there is a legal claim, it's just peer-to-peer file sharing. That's what caused the stir in the music business. So what's really important to understand is that any value-sensitive infrastructure needs all three of these elements in order to function. And one of the key issues that are important here is the notion of decentralization. Because what happens when people discuss these issues, they will say, well, as I indicated on the earlier slide with Web 1, 2, and 3, what people will say is, well, Facebook is highly centralized. Google is highly centralized. They own search in most countries. The main social network in the world is Facebook's consortium of Facebook, Instagram, and WhatsApp. And the point is they have highly centralized power. So should we split them up, or what should we do? Whereas people then in the blockchain world or distributed ledger world will say, but blockchain, they are inherently decentralized. And so in order to just unpick that a bit, we need to really look at it carefully. So whenever people say Bitcoin is decentralized, they are wrong and right at the same time. So if you make the distinction here on the right side from before between somebody making an app on an app store, which is a service creation, a service offering, and then doing that on a particular platform that then will capture the value and maybe distribute it to the ones who offer services, and then the infrastructure, which is enabling the delivery of these services. Then the first observation is that most people who access a blockchain, they're not what's called running a full node. So most people who buy and sell Bitcoin or Ethereum, they don't have all of Bitcoin running on their phone or indeed on a computer, bespoke computer. So the 7 terabyte or whatever it is currently the size of Bitcoin's blockchain, it's not sensible that we all need to run that. So it's only a certain number of entities, I can't remember how many thousand, the entities that run, for example, Bitcoin. But most people will access through what's called a light node. So this is a platform. It can be an exchange or wallet company. And it's really just, and they run a full node. And then on behalf of you, they access the full node and they take a small fee for allowing you to transact your pounds into Bitcoin or whatever you want to do. So that means already there's a difference between in terms of centralization. There are many other ways of centralization, namely in the mining effort. If there's a lot of Bitcoin miners that have a lot of power, then that is a form, of course, of centralization. The other way to look at this is really to say, well, there's different kinds of value-sensitive infrastructures. The two main ones are the permissionless and public ones, and the permissioned and private ones. So Bitcoin is a permissionless and public blockchain. That means that validators can be anonymous or they can be pseudonymous. That means that they have to have a fixed address that might be unpicked somewhere, but they don't have to be named. We don't have to know who they are. And you don't have to have permission to become a validator. Anybody can install Bitcoin and start mining Bitcoin. That's open. Whereas something like TradeLens that I'm just showing in the next slide is an example of a permissioned and private blockchain. It is you have to become a member. And the server you run from needs to be on a whitelist in the collective. So this is a way of saying we are a consortium of people or organizations, and us in our collective, we only trust each other, and we only are the ones who use often proof of stake to vote on additions to the blockchain. It makes it much more energy efficient and makes it much easier, but also in that sense less decentralized. So there's a number of issues in here, and one of the most important ones we need to discuss when you discuss these value-sensitive infrastructures is if the token, if the legal right that is digitized that they take care of is that one that's born out of the blockchain like Bitcoin. So Bitcoins are made by the Bitcoin blockchain. They didn't exist before, and they're made in a regulated pattern, in a regulated process that ends in 2140, I think, if everything goes to plan and the cockroaches haven't taken over the world before. So the point is here that that means that the only cheating that can happen if somebody managed to subvert the system after the Bitcoin has been born. But if you wanted, for example, as the Food Standard Agency in the UK wanted to do, to keep track of meat from cows in order to avoid a new scandal like the mad cow disease scandal some years ago, then it's slightly different, because the onboarding of the token, that you tattoo the ear of a cow and that number is a token that you put on the blockchain. Well, you have to make sure you trust that whoever is branding that cow is doing it correctly and not cheating. And so this is always the big problem, that you can make these consortium because you don't trust each other fully, but you have to trust each other enough that you don't cheat when you onboard the tokens. This is really important. So one example here is one I've been involved in through a PhD student, Thomas Jensen from Copenhagen Business School, who was the guy who did the key ethnographic work of understanding what happens with paperwork of containers that are transported around the world. So he did these container safaris, trying to follow the container and see what happened and what happened with the paperwork of the container. So this is, I have a paper that describes that in great detail from Thomas and some colleagues, and I have his PhD as well. But the point is, it's really about how can we make the paperwork of container traffic much more effective. And one of the ways of doing that is to have a blockchain that encapsulates these documents instead of them being faxes and letters and couriered documents and stuff. And so this is a really successful arrangement between the different shipping agents, the shipping companies, 5 of the big shipping companies in the world. And so it has nothing to do with a new kind of currency, although the bill of lading, which is a document that allows you access to a content of a specific container, of course, can be bought and sold on secondary markets once it becomes part of a blockchain, whereas when it's a fax, it can't. So this is really important, that there's a lot of new innovation that can happen on top of it once you digitize. We're sort of getting towards the end here, and I wanted just to say, when people say that Bitcoin, for example, is decentralized, what they often mean is that it is a first order of decentralization. So what it really say is that all the servers are distributed around the world. So that means if one server is taken out by an earthquake, it still exists because all the data is replicated and worked on by all the other servers. So that is correct, but what you can say is it is really logically centralized. So it is physically decentralized or distributed, but it is logically highly centralized because there should only be one truth. The blockchain that is copied to all the servers around the world should be the same on all of them. That's the whole point. So it is logically highly centralized. And the way my colleague Enrico Rossi, who's actually a UCL research fellow in a large project with my colleague Will Venters here from LSE, so Enrico and I, we did a blockchain course, online course for LSE, and we are working on a few papers on this. And our argument is simply that you have to think of second order decentralization, which we'll give an examples of here. So one of the key examples is the coin relation to the community. So if you establish a new digital infrastructure that knows about value, that has a notion of a scarce digital right that is transported between the members of this community. The key question is, how were the coins made? Were they all made up front? Are they all owned by one man or woman? Or are they not owned by anybody or being distributed over time? So Ripple is a company that has all the coins, XRP, were pre-mined up front. So that is clearly less decentralized than Bitcoin, where the coins are being made as we guess these puzzles. So we have a very, very long paper of over 100 pages that describes these figures, if you want. But this is a very complex discussion. But just to say that really we need to understand decentralization in a much more comprehensive manner. So the last couple of slides are more pragmatic. They're really just to try and say, so what's going to happen and why might this be interesting for most people? Well, the first thing is to note what the discussion in this world is. So clearly, there are lots of companies and collectives that are building these new infrastructures on top of the open internet that allow you to join and therefore exchange these tokens. And so the two main groupings are either what you can call the Bitcoin bros and brodettes. So they are people who believe that Bitcoin is the religion. Satoshi Nakamoto is God, and he is as elusive as God, and that Bitcoin will take over all the global financial system at some point. Or maybe it'll be Dogecoin, so we bank on both, or maybe Ethereum, maybe Cardano. But the idea is that there will be a blockchain-based global economy, and therefore they are hoarding all the Bitcoins they can invest money in as much as they can afford, and sometimes more, because they think each Bitcoin will not be £100 or £5,000, but £1 million or £10 million worth. So I bought some Bitcoin in 2011 and I sold them shortly after. If I'd kept them, I wouldn't have this job. I would probably be on a tropical island drinking a pina colada, but I'm not bitter. It's okay. I have a nice life as it is. But the other grouping are the ones like TradeLens, like Maersk shipping agents, which say that all this Bitcoin is trash. It's really silly. It'll never be the new financial system, but it can be used for large companies to sort out practical problems between each other or within large global corporations. And my observation by studying the open internet from 1993 and onwards is that the most interesting things come out of nowhere where you didn't expect them. And they'll be somewhere in the middle. So a good example of that is the Facebook-led consortium Libra, now renamed Diem as less ambitious, but it was really meant to be what's called a stable coin. So that's a cryptocurrency that is linked to fiat currencies, to ordinary money, to national currencies, so it doesn't fluctuate in value. And this was really important for big companies because they don't have to have the worry of whether the rates of dollar and pound fluctuate, and what about the Argentinian this and the Zimbabwean that. They can just have an internal account in Libra and it'll remain stable, and they can just do that, use that as the internal currency for sending money backwards and forwards within companies. Whereas if you're a WeChat, a WhatsApp user, or an Instagram user, or a Facebook user, then you'll be able to use it as though it was a Bitcoin. You could just send money to each other very easily within. So this project made all the central banks in the world shake their booties. So they all started projects on digital currencies to try and work out how can we avoid money becoming privatized. And that's an important project, where China is already experimenting in action, real-life experiments with the digital yuan. So the way to look at this is really, well, what happened in the good old days was we had these, in the top left-hand corner, these really large organizational pyramids that were very ineffective in meeting innovation demands from consumers, primarily. So they tried to become more flexible by outsourcing and having internal markets and all sorts of stuff. And what these platforms have showed is that the digital platforms can beat all of these and the high street on top of it, because they're so effective in matchmaking people who want to buy and sell from each other. The point is, however, they suck up all the data. So there's a lot to be said for more distributed arrangements that allow us to exchange things with each other over these value-sensitive infrastructures. And it coincides with, of course, the more broader understanding of how can we use technology to establish more privacy. For example, the Hub of All Things, which is a research project based out of Warwick, but with other partners. Tim Berners-Lee has a startup that tries to allow us to own our own data. So all of this is really important. And I think you can say from a human-computer interaction point of view, the assumption I would see as an outsider, I would see the assumption of the open internet has enabled all sorts of new services. But I think this kind of infrastructure will increasingly allow for other kind of services. That means the way people who research and do HCI for a living, it will have to follow this. I mean, a little example is we went to visit one of the companies in London that does Consensus, it's called. They build a lot of services and consult for Ethereum. So their owner and founder of Consensus is Lubin. He was one of the founders of Ethereum. So he's spending his own money on trying to help this project. And they would readily admit, and this was a couple of years ago, that if you are from complete start to finish, if you want to buy a fraction of a Bitcoin and use it for anything, it's at least 37 clicks. So there's a need for some usability. It's not that bad anymore. It's going very fast now. In particular, if some of the exchanges that have apps that are very user-friendly, for example, for Bitcoin Cash and other things. But the point is, there's a massive challenge in terms of individual usability. And as Simon Dixon, who's a very big Bitcoin holder from very early on, he said when we interviewed him for our course, he said, well, maybe the purpose of all of this Bitcoin stuff is just to teach ordinary people how to keep track of things that are both valuable and digital. And this is not something we're used to. And there are lots of stories. There's a famous story of a guy from, I think, Derby or Coventry, who had mined some Bitcoin on his PC early on that is now worth more than $500 million. He managed to throw the PC away, so all the Bitcoin is now stored on the hard disk. And he's trying to convince the local council of helping him to dig out the whole place to find his hard disk, so he can get his $500 million worth of Bitcoin. And he'll give them 25%, but they're not having it because they know it's a fool's errand. So the whole idea is this idea from an individual point of view. Custody of crypto is a huge issue. And it's a huge usability issue. And it will constantly change as we use this for more and more different things. And I think it's an interesting challenge. And in essence, I think what I would say is that, that it's a multidisciplinary problem. This kind of value-sensitive infrastructures, if they become really commonplace and used by everyone, then you cannot say, I'm only a human-computer interaction expert, I'm only an IS professional, I'm only an economist, for example. No, the whole point, because the close couplings between the coin, the network, and the community is the problem is so inherently multidisciplinary that it's very difficult to separate the issues. So this was the end of the formal presentation. I will just show you, but not go through. I have basically put in slides to a report I wrote that relates to these things, some books on blockchain, books on platforms, digital platforms, a lot of books on digital infrastructures, and just some information about myself and the references I mentioned. A website we did as part of the project we did many years ago, and then further slides on decentralization. But all of these are not essential for now, only for the specially interested. And then El Salvador, okay, here we go. Yes, somebody already had the answer. So there are really, as one of my colleagues from the finance department, he said when I had a pint with him yesterday evening, he said there are only ever two kinds of countries that want to use cryptocurrency as a legal tender. And they are either dictatorships who want ultimate control over spending, such as China, and maybe to some degree Russia at some point, or countries that you could say are failed states. He didn't say it like that, but he said states that do naughty things with their money. They take more money out than they have. They don't have a balanced system. So this is like El Salvador. Yeah, it's because they have problems with their money. Otherwise, they wouldn't do it. Very good. That was it for me. Any questions you have?